Hello, my name is Mohan Purnachandra, and today I'll be presenting my final project of the container technology course. Uh, in this project, I'll be deploying a dummy application called CloudShop in an Kubernetes cluster on AWS. So, the architecture of this project is as below. The internet client can access the front end of the app through the load balancer. The load balancer connects to the front-end pod, which is in the port 3000, and the service type of this pod is load balancer. So it gets connected to the internet client. So and the front-end pod is connected to the API pod through port 5000. It accesses the visits and background jobs information from the API pod. The API pod and the worker pods are connected to the Redis pod, which is on the port 6379, and these three pods are in the cluster IP, so they cannot be accessed outside of the cluster. So this is a very safe architecture where only the front end pod is connected through the load balancer and to the internet. The entire cluster, this is the entire node group. I have two worker nodes running in this, and the AWS managed control plane manages all the kubectl commands and allows the AWS CLI user which I have created to run these kubectl commands and get the pods, run services, and apply changes to the clusters. So I'll just demonstrate my kubectl commands to see how it works. So when I do kubectl get pods, I have a total of 8 pods. So each deployment, each service has 2 pods, and they're all running. And when I do a kubectl get service, yeah, there are 4 services in which 3 are in cluster IP and 1 is in load balancer. So only we get one external IP, which is a elastic load balancer. And if we check this in the search engine, yeah, so if we run this in the search engine with the port 3000, then yeah, we can see the app running. So yeah, as I reload, the number of visits increases and the background job changes is incremented by 1 every 5 seconds. So yeah, we can see that the background job increases by 2 here. Yeah, this is the working of this app, and the hyperscaler is performing fine, and this is the repository of this app, and I've also implemented the CI/CD pipeline. So when I commit something in this app, it is it directly gets changed in the GitHub actions get activated and new images gets created. Yeah, so I'll just check with the VS code, just a second, and we'll create a new, like we'll update the front end app so that uh, we can see any reflection of that in the original app. So I'm opening my VS code, just a second. Yeah, so this is the VS code, and this is the frontend app.py. So here I'll be just editing this HTML file and add happy deployment. So now I'll commit this to the Git repository, git add dot git commit. The messages, the, the messages, testing CI/CD, and I'll push this origin main. Yeah. So as soon as this is pushed, I can check in my repository that a deployment action, GitHub action has been created and it is running. So yeah, this is the testing CI/CD which I just ran, and we can see like it all gets logged in to the ECR. API image is being built, and the worker image is being built. The front end image is being built, and it's all pushed to the ECR. This is the ECR. I have the 4 repositories and they keep on updated. Yeah, and I'm using Helm upgrade install my release 1, and yeah, you can see that this is the 12th revision and I've restarted the pods. So now we need to see some changes in this. Yeah, so we can see that the happy deployment has been coming. So this was a CI/CD pipeline, and yeah, everything ran well, and this entire pipeline ran. So this is the CI/CD implementation, and yeah. So just one last thing, I wanted to show the code base. Yeah, this is the deploy.yaml file, which contains all the commands to run in the GitHub actions. So this is all about the entire project. Thank you.